Hello everyone, I hope you're doing very well. In this video, I'll share with you a presentation that I've done for an experiment I did at my last semester in university in a physics lab. This presentation is titled by Electron Spin Resonance, or E.S.R. The objectives of the experiment were to study the importance of E.S.R tool and where we can use it in our daily life. Also, the other one was to determine the Lambda G factor, and for this one, we used a sample. The sample here was TPPH crystal. Well, in this video, I'll be telling you why I used this crystal as a sample. So, what does E.S.R stand for? As I mentioned before, it stands for electron spin resonance, and it's a method for studying the material that has unpaired electron, and this measurement tell us where we have unpaired electrons. So it tells or it points the existence of unpaired electron. Also, the E.S.R is called E.P.R, and it stands for electron paramagnetic resonance because it measures the microwave absorption by paramagnetic center, also with one or more, but most importantly, the unpaired electron. Okay, the E.S.R method is used in agricultural research, and it's used like widely in the production line for semiconductors, for coding things, and it's used also in a medical field and maybe sometimes for healing cancer. As you can see in this photo, this is the device of E.S.R. Okay, there is another short form similar to E.S.R. It's the NMR. It's an analytical method in chemistry, actually, not in physics. It's to study the purity of sample. Okay, so before we just go on, I wanna introduce some concepts for you. The first one, the energy of photon, which is here, which is in yellow. It is that delta E, or the energy, equals Planck's constant multiplied by the frequency. The other one here, the H node, the yellow one, it's Lamour frequency, and it's called the moment process of the intensity of the magnetic field. Okay, so it gives the relation that's called Lamour frequency, and it's given here. You can see this relation, and of course you can just have it in your mind. We have G here. G is the Lambda G factor. Okay, what is Lamour's frequency? Lamour's frequency is the rate of processing of magnetic field of the proton around the external magnetic field, of course. So what is the Lambda G factor? As we said before, the Lambda G factor was one of the objectives that we wanted to determine. So Lambda G factor is an expression of energy level of an atom in magnetic field, and it describes the impact of electron spin of energy according to its angular momentum. So here we have a relation or a formula for finding G, where we have J is the total electronic angular momentum, L is the orbital angular momentum, I'm really sorry. S is the spin angular momentum, and it could be like positive or minus half. So lambda G factor is a constant for like the same material. Like it's constant for the same material, it doesn't change. Why? Because it does not depend on the frequency, and it depends on the energy of the relating the spin, okay, the energy that relating the spin with the magnetic field and the wavelength. So G factor is dimensionless. Okay. The behavior of paramagnetic material and magnetic field depends on the interaction between the particles. Then it needs to reach out to the equilibrium state, as we all know. So we have a concept, it's the relaxation and saturation. So what is a relaxation? Relaxation is when the electron returns from an excited state to the ground state or relax back to the ground. Okay, and we know it needs a short time. Okay, so saturation, what is saturation? Like in the spin the electron of the electron, it does not have time to relax. So if the energy is supplied at fast rate, which means no additional energy is absorbed, this whole situation is called saturation. So in this experiment, two linear relationships are used here. But first, I'm going to tell you why we use the DBPH crystal. Actually, the DBPH crystal has this structure, and it means it has one unpaired electrons. And let me tell you what is the short form stand for. It's that diphenyl becryl hydroxyl. Okay, the DBPH crystal has many properties. The first one, it's a dark colored crystal. It's dark. It consists of a crystalline powder, and it has free radical molecular, and it has unpaired electron, which is the most important property for this material, and its orbital contribution to magnetic field is not there. We cannot see it, okay? We ignore it. And the lambda G factor as non-theoretically it's 2.036. Okay, now here in the experiment we did many things. We find the relation between Q and 1 over I. 1 over I is 1 over the current supplied from the coils we have, the Helmholtz coils, and the Q is known as the displacement or the space between two states, okay, where the splitting happens. Okay, this is G as a relation. Okay, we have another relation. It's also between Q and the frequency. We change the frequency and we find Q. These are calculations used in the experiment. This is the setup. We have the spectrum of E.S.R, the oscillator or oscilloscope, sorry, and the Helmholtz coils. Okay, why we used Helmholtz coils? Because it produce uh, a region of uniform magnetic field, and the two coils are identical, so they cancel just any external magnetic field, like the famous one, the Earth magnetic field. Now we have this procedure of the experiment. You just can read it. It's very easy. And from these steps, you can do the previous two relation I mentioned between Q and 1 over I and Q and the frequency. So you can just have these tables and data and this plot is between Q and 1 over I, and from it we found G with 14. Yes, this G was 14.0 98% error. The other one for the second relation between Q and frequency. And we had 3 G's. All of them are just near to the theoretical value. We had source of errors for sure, personal ones, errors like for by measuring the distance between the peaks, which is Q, the calculations like by instruments, and like too many things in devices. So this was our experiment for today. I hope that you're okay with this presentation. I put my email in the description box, description box, not bug. So you can just, I can give this one for you. I can give this file for you because there's no right. I did it for myself. So just text me if you want it. I hope you enjoyed the video. Bye bye.